Today we're going to be talking about actual versus expected spending that can be observed coming out of a contract management system when combined with an AP file. We want to understand how actual spending tracks to expected. We want to be able to see the issues early. We've got a dashboard here. We'll go through that. And then we want to use that as a way to focus resources to go fix the outliers. What we're trying to do here is we're trying to use divergence that we observe between two spend lines. In our case, we've got an actual spend line that we see from the AP file and an expected spend line that we see from the contract file. For a couple of them here are diverging. We have a statistical way to go determine the divergence. So that's number one. The second KPI that we're looking at here is to actually convert that divergence into dollars. And the way we do that through an artifact, because the slope equals a run rate, we simply multiply the slope times the number of periods, and we've got an annualized view of divergence expressed in dollars. So clearly you want to have stuff that where you're overspending, the divergence is high, that's the focus area. So we have a dashboard. Now you can see here, this is the underpinning view, a layer down in the blue, expected spending that we observe from our contract system. Orange is up to about here is the spending we see out of the AP file. And so we simply apply a regression line to our spend curves. Are these lines diverging or not? In this particular situation with Oracle is 2.35. You can see the blue is over the orange. Life is good. Now the way to interpret it is from 0 to 2 standard errors, normal, life is good, everything's fine. 2 to 4 standard errors, we should be watching it. Over 4, we have an issue. So that's the interpretation of the standard error metric. So the lesson plan is going to happen in two pieces. And the first is to recognize the attributes of the presenting tables. Specifically, we need to locate, clean, and normalize the data files. And specifically, this is the heart of the matter, which is what are the measures that we need to make this happen? So what you see here is the dashboard that was represented in the view. And these are hot, so you'll notice as we shift around, these numbers are hot, models live. When we change the time period, we change the KPIs. Get rid of this. Let's go back to our start point. So now let's go a layer down, and this is what we saw before. Again, this is also hot. We go forward. We can see the model jumps around. The standard error metric jumps around as well. Let's go back to our 2.35. And we've got other suppliers here. We want to go to Teradata or Experian, which is a real, Experian's got a problem. So you can see the slicers are hot. We've got sub-second response time. So this is the view that feeds into our bridge table. All right. So let's now go back down to how these things are actually computed. We can see here, we're looking at Oracle. We can see we've got a slope for the AP, the accounts payable file. We got a slope for the expense file. And if we change this, you can see these slicers are hot, and we can see the numbers, the numbers change. Linus measure is a recent addition to the Power BI stack. It's maybe 6 months old. Well, now we can bring all of that into a Power BI environment. So the Linus function outputs 10 variables, and the very common slope, intercept, and we're going to use slope and standard error. We're not going to use the variance. We're not going to use the intercept. Again, so the definition, just to go through the definition again, the standard error computation determines whether the difference between the two slopes, this versus that, statistically significant based on the variability of the slopes, number one, and the associated standard errors. It's a combination calculation, a metric, a single metric to determine the scope of the divergence of your two lines. Very powerful stuff. One more thing just to our previous version. Let's just go here and remove our trend line. You can see what we've got left with here is the expression forecast. And when we bring in our system-generated regression line that want to combine, we're going to remove the combine, you can see that the system view of the regression line is identical to what we've computed. So this is the check to make sure that the regression lines and coefficients are accurate, etc. What I've observed in doing this is that fully 50 or 60% of the time, it's in fact the contract side that is not accurate. Contracts are missed, never got circulated correctly. Every once in a while, you'll run into something that a change in the infrastructure, that kind of thing. Hope that helps. Give me a buzz if you've got any further questions or comments.